Do you know how to fairly easy identify first-order transfer function parameters? Hello, Christopher here with PiControl Solutions. Today I will show you how to visually identify parameters of the first-order transfer function with a delay. The parameters are process gain, dead time, and time constant. The first one is a process gain. For every change in a manipulated variable, there's a change in controlled variable. Simply by dividing the values of two changes, we get the process gain. Process gain unit is a combination of process units examined. And let's say in our example, we have a change in flow by 15 kilograms per hour, caused by step change in control valve by 3%. This gives us process gain of 5. Next one is a dead time. For this one, let's zoom in our example. Dead time is a difference between starting times of two set changes, change in controlled and change in manipulated variable. Dead time unit is usually seconds or minutes, and let's say in our example, controlled started at 110 seconds and manipulated started at 101 seconds, leaving us with a dead time of 9 seconds. Time constant is a time required for the controlled variable to reach 63% of the total final change from the starting point of the change. Time constant unit is usually seconds or minutes, and it's really easy to solve it. First, we multiplied the full change of the controlled variable by 0.63, and then added the result to the value of the CV before the change. Then simply find the time of 63% change and subtract it by the start time of the CV change. In our example, it's 40 seconds time constant. Now, let us simulate an example and visually identify first-order transfer function parameters. For the simulation, we will use our SIMCET PID tuning simulator software. This is a real-time online PID tuning simulator. It is made exactly as if you are tuning loops in the real plant. But for now, we will make simple step test in the manual controller mode to generate first-order process for which we'll identify function parameters. It is of course possible to save data and use it in any data processing applications such as Excel. Let's now make the change of the manipulated variable. While we wait on the controlled variable change to stabilize, let me encourage you to check out our website where you can find informations not only on SIMCET but other products from PiControl Solutions. Also services we offer to industry and academia, and the trainings we teach of which we are very proud of. Let's now save the data, which is by default saved in CSV format, easily readable by any data processing application. Now let's start with process gain. After the change of manipulated variable from 50 to 60% in valve position, the change of controlled variable went from 7 to 17 kilograms per minute. 17 minus 7 divided by 60 minus 50% gives us process gain of 1. Next up is dead time. Let's zoom in a little bit and find starting times of two changes. The change of controlled variable started at 170 seconds. The change of manipulated variable started at 162 seconds. 170 seconds minus 162 seconds leaves us with 8 seconds dead time. Last one is time constant. We already established the change in controlled variable, which is 10 kilograms per minute. Now, multiplying it by 0.63, we get the value of 6.3. Adding this value to the value before the change, which is 7, we get 13.3. Now we simply read off the time of 13.3 change of controlled variable and subtract the time of start of the change from it. It is 202 seconds minus 170 seconds, which is time constant of 32 seconds. Make sure to subscribe to our channel for more process control tips and tricks. This was Christopher with PiControl Solutions.